Our second question on Objective 5, ammonium chloride is dissolved in water. Ammonium is our positive polyatomic ion carrying a +1 charge. Chloride is a negative ion, and when I hook by charge, we get NH4Cl. It will start as a solid on the left-hand side and dissolve into water. When we take a solid ionic compound and dissolve it into water, the ions are released. They're held together by opposite charges on the solid, but the water forces them to separate through the process of dissolving. Now, when ammonium ion forms in the water, it carries its charge. Ions only exist in a water medium. The other ion that forms is called chloride ion. It is also aqueous. Friends, there's a very big difference between a chlorine molecule that exists outside of water in a gaseous form and a chloride ion that exists in water. Cl2 would be its molecular form. Cl negative would be the form it would take when dissolved in water. So when I write the product over here, chloride, Cl negative 1, the ionic compound ammonium chloride, releasing ions. This product is not written in its molecular form, but it's written as its aqueous ion, Cl negative 1. Notice then the number of ions come out balanced. We'll just tack on the delta H information. This has a clue here, says absorbing energy. This has a value of positive 182 kilojoules of heat. Our balanced thermochemical equation for the process of dissolving ammonium chloride. In our letter B, how many grams of ammonium chloride must be dissolved in water so that 500 kilojoules of heat is released from the water? Ammonium chloride absorbs the heat. The water is releasing the heat. 500 kJs is our given. We want to know grams of ammonium chloride. This would look like a step 2, step 3 on our stoichiometry roadmap, where we begin with the heart of our problem. If I'm given the kJs had better cancel. 182 kJs, the value from our balanced equation, gets placed on the bottom of the want over given ratio. We see that 1 mole is the coefficient in front of ammonium chloride. Now to convert out to grams, we'll need a molar mass of our compound ammonium chloride. 14 on the nitrogen, 4 more on the hydrogen, 35.5 on the chlorine. Looks like 53.5, the molar mass of our ammonium chloride compound. Hitting through with me, 500 divide by 182 times 53.5, and I have 146.98, about 147 grams of ammonium chloride. In our letter C, again, a stoichiometry problem still sticking with that original equation, we'd like to know the enthalpy change, and enthalpy is just what we call delta H, when 3 moles of chloride ions are given is the chloride ion, and we want to know the enthalpy change. We're already in the heart of our problem. Given the number of moles, we don't need a first step. It's simply a one-step conversion since we're already given the mole unit. We want to know kJs given the number of moles. Now the chloride ion, Cl negative, is being compared to the number of kilojoules of heat. We want to know the kilojoules, positive 182 kJs on the top for every 1 mole of chloride ions that was released. 3 times our enthalpy value of 182 gives us 546 kilojoules of heat that's being released into the water. 546 kJs, our answer. Predicting that A+ come Friday's test, are you?